Hello, Algebra 2. This is your video that's going to go over the optional review. Please remember, the mandatory review is on Delta Math. This one's just an extra review. I'm going to go over select problems here, starting with example 1, where they want you to find all the zeros of the polynomial function provided the given information. But I'm going to expand on these problems whenever I can. So for example, you're going to need to know what degree polynomial this is. And in that case, it's fourth. You're going to need to know what is the name of a fourth degree polynomial. That is quartic. Now, what else you're going to need to know is if it's a fourth degree polynomial, when we find the roots, how many solutions should we expect? And that would be 4. Whatever the degree, that's how many solutions your function will provide. Let's find them. All right, looks like we can factor this trinomial a times c, 24, and indeed we can. 4 times 6 is 24, and 4 plus 6 is 10. The leading coefficient is 1, so I'm going to save myself some time here. I'm going right to factor form. Now, you might be thinking to yourself, hey, we can factor this further. No, you can't. If this was a minus sign, you could, but it's not. Now, that doesn't mean it can't be solved, though. We're going to set what is in the parentheses equal to 0. And we're going to use the square root method. Yes, you've been taught this, but we haven't done it in a while. So subtract 4 from both sides. X squared equals -4. Square root both sides. And x equals plus or minus 2i. The square root of 4 is 2, but the square root of -4 is 2i. Now over here, subtract 6 from both sides. X squared equals -6. Square root both sides. X equals plus or minus I root 6. And we have now found our 4 solutions. One of them is positive 2i, negative 2i. One of them is positive 2i, the other is negative 2i. And then we have I root 6 and negative I root 6. See? 4 solutions. They're all imaginary, which means this graph will never cross the x-axis. We don't have any real solutions. Okay, we're now going to skip to example 4. Looking at example 4, given the factor, name the zeros of the function. If they present you a problem that looks like example 4, they're trying to give you a hint. They want you to use synthetic division or long polynomial, but synthetic is faster. Whatever the factor is that they give you, set it equal to 0, solve for x, and that's what you want to use to divide this problem by. Before we get going, though, looks like this is a third degree polynomial. The way that I can tell that is, well, let's see, we have an x cubed, x squared, x, and a constant. X cubed is the highest of all the exponents. Therefore, it's a third degree polynomial. A third degree polynomial is called cubic. And if it's a third degree polynomial, you can expect to find 3 solutions. Let's go. Whatever that is, bring it down, don't change it. And now we multiply. -4 times 3 is -12. Let's add. 10 plus -12 is -2. Now multiply. -4 times -2 is +8. And now we add. -16 plus 8 is -8. And now we multiply. -4 times -8 is +32. We have reached the end, no remainder. We're now going to bring down our variables, and you're going to decrease by 1 exponent. Now, let's continue solving. Number in front times number in back. This one can be factored. 4 times -6 is -24, and 4 minus 6 is -2. Unlike the previous example, however, we cannot take the shortcut because our leading coefficient is something different than 1. You have to create a grouping problem. There we have created our problem here. Now we're going to group. Group 1, group 2. At a group 1, you can factor out an x, leaving you with 3x plus 4. And at a group 2, you can factor out a negative 2, leaving you with 3x plus 4 again. Okay, now we have factored. You now have to set each of these factors equal to 0 and solve for x. I've run out of room here, but hopefully you'll know what to do at this point. X minus 2 equals 0. If you solve that, you're going to get 2. Here, 3x plus 4 equals 0. If you solve that, you're going to get negative 4 over 3. Now, at the beginning, I told you we should have 3 solutions because this is a cubic function. I found 2 of them. Here's the other one. Remember what we divided by? Negative 4. Now we have found all of our solutions. Oops. All right. Follow the script for us. Let's take a look at 6, and I'm going to zoom in. Give me just a second. Okay, here, this is a 4th degree polynomial. Now, it doesn't tell us to solve, but what you need to know is if it's a 4th degree polynomial, you will have 4 solutions if you solve. You also are going to need to know that since it's a 4th degree polynomial, we call those quartic functions. And now we're going to do our end behavior here. If your degree is even, that means your end behavior is going to be exactly the same, either up, up, or down, down. The determining factor is the leading coefficient, which is positive. Yes, it's positive too, but the most important thing is that it's positive. Since it's positive, that's going to be our result. Up arrow, let's put a positive infinity here. Up arrow there, so you're going to put a positive infinity there. These up arrows mean they're going to positive infinity. Okay, here. This is a 3rd degree polynomial. Therefore, it is a cubic function. And if it is a 3rd degree polynomial, that means your end behavior is going to be opposite directions. Now, I said if it's a 3rd degree polynomial. What I meant to say is if it's an odd degree. So if it's an odd degree, think opposite arrows. It's either going to be up, down, or down, up. The determining factor is what is the leading coefficient, which is positive 1. The key factor meaning positive, meaning your last arrow must be heading towards positive infinity. Now we can do our end behavior. For this blank, looks like we have a down arrow there, so let's do negative infinity. For this blank, looks like we have an up arrow there, so let's do positive infinity. All right, let's move on. Example 8, let's see, are they trying to trick us? No, this is in perfect order. It looks like this is a 4th degree polynomial. Quartic is what we call 4th degree polynomials. If it's even degree, that means your end behavior is going to be going the exact same direction, either up, up, or down, down. The deciding factor is now what is the leading coefficient, which is negative. So our end behavior is going to be down, down. So since both of those are down arrows in these blanks, put negative infinities. Over here, this is also in perfect order. From highest exponent to lowest, we can tell that by that number 5 here, this is a 5th degree polynomial, and we call those quintic. Now, if you had to solve this, which you don't, you would get 5 solutions. 5th degree, 5 solutions. Odd, since it's an odd degree, that means opposite end behavior, odd, opposite. It's either up, down, or down, up. The deciding factor is the leading coefficient, which is negative, meaning your last arrow has to be heading towards negative infinity. So now we have our winner. That arrow is pointed up, so in the first blank, do positive infinity. The last arrow is pointed down, so in the last blank, do negative infinity. Okay, we're going to now move on to example 13. Yes, I'm going through this quickly. Part of the reason is I only have a certain amount of time today, but the other reason is I think that you can slow these videos and speed them up as much as you want. Of course, you can always rewind and pause and all that stuff. Find the y-intercept of this function here, number 13a. Now listen, I've been doing this a really, really, really long time. I can tell that this is in standard form. Therefore, it's the constant. Your y-intercept is 2. But if you don't remember that, hopefully you'll remember this. To solve for your y-intercept, wherever you see an x, plug in a 0 and solve. Okay, well, 0 cubed is 0, and 0 times 2 is 0. 0 squared is 0. 0 times 5 is 0. What are we left with? 2. So your y-intercept as an ordered pair is 0, comma 2. This is where this might really help you. If you don't know what your y-intercept is by looking at this, let's substitute a 0 everywhere we see an x. Remember your order of operations. Parentheses first. 0 minus 4 is negative 4. 0 plus 2 is 2. Next, take care of any exponent. 2 squared is 4. And now from here, we can multiply. 2 times negative 4 times positive 4 is negative 32. So as an ordered pair, your y-intercept is 0, comma, negative 32. For 14, let's find all the roots of this function. How about let's start with what degree polynomial are we dealing with? 4th degree. That is called quartic. Your end behavior is going to be the same direction, either up, up, or down, down, based on the leading coefficient, which is positive. Therefore, up, up. How many solutions should we expect to find with a 4th degree polynomial? 4. Very good. Let's find them. If you'll notice, every single one of these terms is divisible by x. So let's start by factoring out an x. Now what we have left is a 4-term polynomial, which usually means we can probably factor by grouping. Out of this group, we can factor out a x squared, leaving us with x plus 1. Out of this group, you can factor out a negative 9, leaving you with x plus 1 again. So after we factored by grouping, we are left with this, but don't forget, we originally factored out an x. Now, hopefully, your brain is saying, oh my goodness, x squared minus 9, that's a difference of perfect squares. That can factor again. And yes, it can. And now we set all of our factors equal to 0 and solve starting here. X equals 0. Here, if you solve this, you're going to get 3. Here, if you solve this, you're going to get negative 3. And here, if you solve that, you're going to get negative 1. Okay. Let's now move on to this side. I'm going to start here with this one. I like this one. Anything that you have inside the equation is going to be a transformation left or right, and it's opposite of what you think it would be. So this graph is not going left one, it's actually going right one. Any number that you see to the right of your equation, that's vertical, and that's no tricks there. So this one should be shifting down too. So what that means is this is the origin where a cubic function starts. Our critical point from the origin, we should be able to go right one and down two in order to get to the new critical point, which we have. So is this the graph for this function? Yes, it is. In order to get from the origin here to the new critical point, we had to go right one, down two, right one, down two. All right, now let's look here. Notice that plus 5 is not inside the equation. So this function should be shifting up 5, up this way, 1, 2, 3, 4, 5. So this function would actually produce a graph that looks like this, not the one given. So no. This one here, 1 over 3x cubed plus 3. I don't remember that a fraction is known as a compression. A proper fraction, by the way, 1 over 3, 2 over 5, any number in between 0 and 1. And what that's going to do with our cubic functions is it's going to take the graph and it's going to sort of widen it out a bit. This right here, this graph, is more representative of a stretch, which is going to narrow. So this one would be no. Even though, yes, it's shifting up 3, the critical point matches the vertical transformation. This is more representative of a stretch than it is in compression. All right, now looking at 19. This is where having a knowledge of your parent table comes in handy, and I'm trying to look for my parent table. There it is. Okay. I don't know if this information is going to be provided on your next test, and probably not. So what we're going to do is memorize your values from -2 to 2. Your x values from -2 to 2 is not going to change. These values are the parent table of a cubic function. And even if you don't want to memorize the y values, as long as you remember the x values, you can just simply plug them in and solve. So -2, if I cube that, -2 times -2 times -2 is -8. If you plugged in -1, -1 times -1 times -1 is still -1. So the most important values to remember are just -2 to 2. Now I'm going to start building my transformation table. Inside the equation, x plus 2, that means this graph is actually shifting left 2. So I'm going to draw x minus 2 in the x column. You see that negative in front of the parenthesis? Let's do negative in front of y. And then that plus 1 to the right of parenthesis, we're going to do plus 1 to the right of y. Now what I'm going to do is I'm going to take every single one of these x values, substitute them for x here, and then subtract 2 from them all. So if I took -2, plugged it in here, and subtracted 2, that's now -4. Let's take -1 and plug it in. Subtract 2, that's now -3. How many values is that? 1, 2, 3, 4, 5. Okay. I've plugged in all of my x values and subtracted 2. Here's the result. Now we're going to take our y values, plug them in, multiply them by the negative. It's just going to flip the sign and then add 1. So -8 becomes +8. Add 1, you get 9. -1 becomes +1. Add 1, you get 2. That's still 1. 1 becomes -1. Add 1 to that, you get 0. And then lastly, 8 becomes -8. Add 1, you get -7. These are now the values that we're going to graph. Okay, example 20A, we're going to name the shifts. That 9 that is in front of our parentheses, that is a vertical shift. Sorry, vertical stretch. Of 9. Here we're going right 5. And here down 45. Over here, that negative, that is a reflection over the x-axis. 5/6, that's a proper fraction. So that's a compression, vertical compression. And then here, up 15. All right, let's take a look now at 22. For 22, name, this is in factored form. So let's take a look at our factors and their exponents. If you add them together, 2 plus 2, that's 4. So this is a 4th degree polynomial, and those are quartic functions. Sign of the leading coefficient. Take what's in the front of the first parenthesis, and notice we're squaring it, times what's in the front of the second parenthesis. Notice we're squaring that, and we get x to the 4th. So our leading coefficient is +1. Roots. What are our x-intercepts? It's in factored form. Keep that number, flip the sign. Keep that number, flip the sign. Y-intercept. Take a look at, is there anything in front of the parentheses? I guess you could say 1, but that's not needed. Look at the constant in here. Take that number. Notice it's being squared. Look at the constant here. Take that number. Notice it's being squared also. 2 squared is 4. -4 squared is 16. And my brain is tired today, so I'm going to my calculator. 4 times 16 is 64. That's our y-intercept. Maximum number of terms. Remember, this is a 4th degree polynomial, and 4 minus 1 is 3. End behavior. Well, since it's a 4th degree, that's even. So either up, up, or down, down. And since our leading coefficient is positive, it must be up, 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 positive infinity, up, positive infinity. Now it's going to be very important that you just have an idea what this graph is going to look like. We have x-intercepts at -2 and +4. We have a y-intercept somewhere way up here at +64. Our end behavior is up, up. So I'm going to draw an arrow there and there just to give me reminders. Now, something that you need to remember is that this factor, this x-intercept, which by the way produces an x-intercept at -2, since the parenthesis is being squared, that means when we approach that x-intercept, it's going to bounce. It's going to go towards the y-intercept, come back towards the x-intercept, and bounce there too, because that factor is being squared also. Any factor that's being squared means you're going to bounce at that x-intercept. So that's what this particular graph would look like. Okay, 23, we have some work that we could do here. This right here can be factored. The factors of 4 that can also be combined to get -5 or -1 and -4. We can take the shortcut to go to our factors. Okay, so now that we're in complete factored form, what degree are we dealing with? Well, all of these factors have an exponent of 1. So this is a 3rd degree polynomial, which is cubic. Now let's find our, let's see, let me start filling in some of the stuff. We've already determined cubic. Sine of the leading coefficient. Okay, well, here's what we're going to do. We're going to take the negative there, multiply it with what's in front of this parenthesis, multiply with what's in front of that parenthesis, and multiply with what's in front of that parenthesis, which is going to give us negative x cubed. Our leading coefficient is negative. I'm going to go ahead and put -1. Zeros, well, these are all our factors. X minus 3 means you have an x-intercept at 3. X minus 1 means you have an x-intercept at 1. And x minus 4 means you have an x-intercept at 4. Now, how about the y-intercept? Do we have anything in the very front? Yes, we do. -1. Let's take this constant, that constant, and that constant. We're going to multiply everything together. Notice I have 4 negatives, which means my final answer will be positive. And now multiply 1 times 3 times 1 times 4, positive 12. That's where our y-intercept is going to be. Okay, maximum number of terms. Well, this is a cubic function, third degree, and 3 minus 1 is 2. End behavior. Since it is an odd degree polynomial, that means your end behavior is going to be different directions. Now, which one is it? We're going to take a look at the leading coefficient, which is negative. So then the last arrow must be going towards negative infinity. Up arrow, so here we're going to do positive infinity. Down arrow, here, let's do negative infinity. It's important to have an idea what this graph is going to look like. We're going to plot our x-intercepts. We have one at 1, 3, and 4. 1, 3, and 4. Our end behavior, remember, was up, down. So we could say somewhere up here, and we're going to end somewhere down there. What was our y-intercept? 12, so our y-intercept somewhere here. And then if you'll remember all of our factors, their exponents are 1. So as our graph approaches every one of these x-intercepts, it's going to go straight through them. So let's go through that y-intercept there. We're going to go through that x-intercept. Let's return and go to that x-intercept. Turn around, let's go towards that x-intercept. And your graph's going to look something like that. Okay, 24. Here we have everything that is fully factored for us. You know what I'm going to do is I'm going to take what I have in front there times what I have in front of that parenthesis times what I have in front of that parenthesis, which is going to give me x to the 5th. So we now know that this is a 5th degree polynomial, which is quintic. The sign of the leading coefficient, well, we can see here it's positive 1. Maximum number of turns, 5 minus 1 is 4. And now our y-intercept. Do we have anything in front of our parenthesis? Yes, we do. X cubed times that constant there times that constant there. Oops, why did I do that? Now, if you multiply all this together, you're going to get 5x cubed. That's not a constant anymore. It has an x with it. So our y-intercept is 0, 0. End behavior. We've already established that this is a 5th degree odd with a positive leading coefficient. So down, up. First arrow is pointed down, so here let's do negative infinity. The last arrow is pointed up, so here let's do positive infinity. Okay, you see that x cubed right there? That is one of our zeros, one of our factors. If you set x cubed equal to 0 and solve, you'd have to cube root both sides. And the cube root of 0 is 0. So we have an x-intercept at 0, which is also where our y-intercept is, by the way. Here, we have an x-intercept at 2, 1, 2. And also 5, 3, 4, 5. Our end behavior was down, up. Now, as I approach this x-intercept here at 0, since its factor was being cubed, that means it's going to flatten out. And every single one of these other x-intercepts, their factors, they were an exponent of 1. So we should be going through the other x-intercepts. Okay, be careful with 25. It's out of order. It's x squared and then plus 27. The name of this is a fourth degree. That's quartic. Sign of the leading coefficient, we can tell, negative. Maximum possible number of turns. Fourth degree polynomial, 4 minus 1 is 3. Y-intercept, it's in standard form. There's our constant, 0, 27. End behavior. This is a even degree polynomial, so that means same direction. The leading coefficient is negative, so it stands to reason down, down. That first arrow is pointed down, so in the first blank, do negative infinity. That last arrow is pointed down, so in the last blank, also do negative infinity. Okay, to have an idea of where are we going to plot this stuff, we're going to have to do a little bit of work here. I'm going to start by factoring out the negative. Which is going to change all the signs. And then we have a trinomial here that can be factored. Let's see. 3 times 9 is negative 27. And 3 minus 9 is negative 6. The leading coefficient is 1, so let's take the shortcut. Hopefully you're seeing that, hey, this one can factor a little bit more. Oops. Okay, so this is what it factors to. We have x-intercepts here at 3 and here at negative 3. If you were to solve this, you'd be taking the square root of a negative number, meaning these factors or this solution is not going to cross the x-intercept. We're only going to have 2 real solutions. So we're going to go to our graph here and now mark where our x-intercepts are going to be. 3, left 3. What was our y-intercept again? We've determined it was 27, so somewhere way up here. Our end behavior was down, down, so let me do. Our x-intercepts came from these factors. Their exponent is 1. So our graph is going to go through them to look something kind of like that. Okay, 26. Write least degree polynomial for the graph shown in factored form, then give the domain, range, and end behavior. Assume a equals 1. Let's start with our domain. Your domain here is going to be negative infinity to positive infinity. By the way, if it's a polynomial function, it will always be negative infinity, positive infinity for your domain. But if you just imagine, like this graph is going to go forever, it's going to continue expanding left and right. And domain is what x values does our graph cover from left to right. Now range, if it is a even degree polynomial, which this one is, it's not going to be negative infinity, positive infinity, but we can find it by looking at our graph from bottom to top. Now, I don't really know what that is right there. So we're going to guess negative 1, negative 2, negative 3. It looks like negative 3.5. It looks like this graph is going to cover our y values at -3.5. And then from there, it's going to continue expanding upwards to positive infinity. So that's our range. End behavior. Let's do the end behavior here. I mean, look, the arrows are up, up. So that arrow's going up. So here, positive infinity. That arrow's going up, also positive infinity. And now let's see if we can figure out what is the equation of this function. Here's how you're going to do it. What is that x-intercept right there? -1, -2, -3, -4. So in factored form, it's x plus 4. Notice the graph is going through it, so no exponent. What is that x-intercept? It looks like -1. So in factored form, it's x plus 1. Notice the graph is going through it, so no exponent. And now let's find that x-intercept there. That's at 1, 2, 3. So in factored form, it's x minus 3. Notice, though, it's bouncing at that point. So therefore, that must be squared. That's the easiest way to do these problems. That's your final answer. Okay, 29, domain. This is a polynomial function. It's going to continue expanding from left to right forever. So our domain is that range from bottom to top. Well, we can see that it's coming from negative infinity, and then it maxes out here. It won't go any higher than that point. And at that point, y is 1, 2, 3. Hey, you see these arrows are going opposite directions. That means this is an odd degree polynomial. And if it is a odd degree polynomial, that means your domain and your range is negative infinity, positive infinity. And now what does it say? Write the least degree function for the graph shown, right, in standard form. I like this one. Okay, so here's what we need to do. Y equals, what is that x-intercept? -1. So as a factor, it's x plus 1. What is that x-intercept there? 1. So as a factor, it's x minus 1. Here, what is that x-intercept? 3. So as a factor, it's x minus 3, and we don't need any exponents with our parentheses because our graph is going through every single one of those x-intercepts. Now, this is your answer in factored form. It said it wants it in standard, so we're going to have to multiply. We're going to have to do some foiling. I'm going to FOIL these parentheses first. And now combine like terms. Okay, I've FOILed those, I've multiplied them. So now let me include this one. I'm going to take that x, multiply it there, there, and there. X times x squared is x cubed. X times -4x is -4x squared. And x times 3 is 3x. Now I'm going to take the 1 and multiply it there, there, and there. 1 times x squared is x squared. 1 times -4x is -4x. And 1 times 3 is 3. And now if we combine our like terms, we have our final answer in standard form. There it is. Good luck, everybody.